Okay, let's continue. So in the last class, some of you were a little concerned about the statements we were making because you were saying, well, we're making this statement, but it's not true. The last class, we were just making the statements. Now we're going to see the implications of what happens, whether it's true or false. So let's continue with this, and we're going to talk about something today called the biconditional. So we're going to talk about the biconditional and something called a good definition. So a biconditional is a single statement that connects a conditional and its converse with and. So it looks like this. So it's P implies Q, and Q implies P. The conditional and its converse connected with and. So, and this is which is symbolized as P, which is written like this, right? And read as P if and only if Q. Okay, so let's take a statement, a definition, and write it as a biconditional. A square has 4 sides. Statement. A square has 4 sides. Once again, we're just looking at statements. We're going to symbolize them, and then we're going to think about whether it's true or false. So first, let's write it as a conditional. Write as a conditional. So I'm going to say if a figure is a square, then it has 4 sides. What's my converse? How do I write this as converse? If a figure has 4 sides, then it is a square. We're not talking truth yet, because some of you are like looking at this saying, wait a minute, that's not right. We're not there yet. So we would say, we would write, right? As a biconditional, we would write a figure is a square if and only if it has 4 sides. Right? So we took our statement, we wrote it as a conditional, we found the converse, and then we jammed it together in a biconditional. Okay. A statement a statement is a good definition if what? If the biconditional is true. Can you see that? Yeah. Well, when is the biconditional true? When is the biconditional true? If the conditional is true. And the converse is true. So now we're saying, you know what? Is this a good definition? And some of you are saying, well, I like one of these things, but I don't really like the other one. So well, let's just answer that question now. Is a square has 4 sides a good definition? So the answer is no. No. It is not a good definition. Why not? Why not? Why not? Am I recording? Yeah. Why is it not good? Because, you know what? Because the converse. We don't like the converse. Because the converse is false. And that's why this isn't a good definition. So that's the idea. So the idea with logic is first, get the statements into conditional statements. Then you do your analysis. So that's the 2-part. I want to do a truth table with you guys. So copy this down. Did you copy it down? Good. Okay, now I'm going to, good. So I'm going to erase this. So I'm going to, once again, as I said, I'm going to let's do a truth table. Okay. First things first, remember from yesterday, P, we have P, which is true, true, false, false. We have Q, which is true, false, true, false. And we know that P and Q, because we said we want to connect them with an and, was true and true is true, and everything else, if it has a false in it, is false. Okay, I'm going to make another table. P, Q, whoops. P implies Q, Q implies P, and then we connected these together with and. Okay. Once again, I'm not testing you on this, but if you want to if you like these, if you find this interesting, you know, it's something to pursue. We know that we said true, true, false, false, and we're going to let true be true, false, true, false. Once again, we have all the combinations of our hypothesis and our conclusion. We're mostly interested in true, 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 false, or when we're going to see what happens in the last column. We want to see when it's true. So we know that true implies true is true. We knew when true implied false, it was false. And we knew anytime we started off with a false hypothesis, the rules of logic say our conditional is true. Well, Q implies P. True implies true, true. False implies true, true. True implies false, false. False implies false, true. Next, we want to connect it with and. True and true, true. False, false, right? We have false. This one's weird, right? Now, a good definition, so this validates what we were talking about. A good definition is a biconditional is true when it's conditional and its converse are true, right? That's good. Once again, this is really advanced. Like, this is like college level logic, but if you just make up totally false stuff, You can come up with a good definition according to the laws of logic. Like, I don't know, like green elephants dream, purple dreams. That's a good definition. Pink, like green elephants dream purple dream. Green elephants dream purple dreams is a good definition because according to the laws of logic, false, and false, the conditional and convertible true. So this is weird, but once again, this is what we're interested in. Okay. Let's continue. How about this one? Perpendicular lines meet at right angles. Is that a good definition? Perpendicular lines meet at right angles. Is this a good definition of perpendicular lines? And the answer, I want you to think about it. Write it as a conditional, find the converse. Are they both true? Then you have a good definition. Let's think about that. Okay, let's see. If two lines are perpendicular, then they meet at right, I'm abbreviating, right angles. So I use the symbol, this is the symbol for perpendicular. This is an abbreviation for the word right, and that's a symbol for angle. This is the conditional, right? What's the converse? If two angles create right angles, then they are perpendicular. What do you think? So, what's our last step? So you would say, you know what? P implies Q is true. And Q implies P is true. Therefore, ... is a fast way of writing therefore. We have a good We have a good definition. How would we write this as a biconditional? Two lines are perpendicular if and only if they meet at right angles. I don't want you to focus on that. I want you to think about whether we have a good definition. So a little writing. Write this down. So let's see. A good definition is a statement that can help you identify or classify an object. So here's some important things to know about a good definition. It uses clearly understood terms. And they should be commonly understood or clearly defined. So the terms should be commonly understood or already defined. Like, most people don't know what perpendicular means, but we do because we've defined it. Most people don't know what supplementary means, but we do because we defined it. It is precise, and they avoid terms like large, sort of, and almost. And also, a good definition is reversible. It is reversible. Which means you can write it like we've been doing here, which means perpendicular. If a statement is a good definition, then you can say perpendicular lines meet at right angles, and you could say right angles or lines that meet perpendicularly. You can switch it back and forth. So let's take a look at some definitions. I'm going to erase this. I want you to think about this. Let's see. Ready? First definition. A fish is an animal that swims. A fish is an animal that swims. Next definition. Giraffes are animals with very long necks. Giraffes are animals with very long necks. Definition 3. Rectangles have 4 corners. Definition 4. It's an American thing. A penny is a coin worth 1 cent. Okay. Pause, and then, okay, what do you think? The first one, what do you think? A fish is an animal that swims. Well, the answer, what's the answer? Yeah, it's not a good definition because if we switch it, an animal that swims is a fish. That's not good. No, because the converse, if an animal swims, then it is a fish. That's not always true. What's wrong with 2? Giraffes are animals with very long necks. Okay, good. Well, the first thing is very long. We're math people. We don't like that. We want, this is not clear. And then secondly, what's the problem? The converse, once again, is no good. Also, the converse fails. If an animal has a very long neck, then it is a giraffe. Well, can someone think of an animal that has a long neck that is not a giraffe? Yes, Eliza? Yes, very good. An ostrich. An animal with a long neck is giraffe. If an animal has a long neck, then it is a giraffe. Not always true. So no, it's not a good definition. No. Rectangles have four. Sorry. Rectangles have four corners. First of all, so what do you think? First of all, corner. What exactly is a corner? This is not clear. This one. So this is no. No. First, corner is not well defined. And second, what's the problem? Once again, the converse is just not good. If a shape has four corners, it doesn't necessarily mean it's a rectangle. No, the converse fails. The converse is not true. Or it's not reversible. Last, a penny is a coin worth 1 cent. Yeah, that's good. If something is if a coin is a penny, then it's worth 1 cent. If a coin is worth 1 cent, then it's a penny. That's good. So yes, this is yes. The conditional and the converse are true. Okay, I'll put the homework assignment on Google Classroom.